Okay, good evening, my dear students. So, welcome to the first lecture on capstone project. No, so for this video, I am going to talk about momentum and impulse. So these are two terms that are highly connected. No, in physics. Later on, there's going to be a theorem that states their connection. So this lecture will be divided into three parts. So the first part we will talk about momentum, and then the second part we're going to talk about impulse and the connection between impulse and momentum through the theorem nga, no, that I mentioned. And then during the third part of the series, I'm going to talk about the application of the impulse momentum change theorem. So let's start. So first, mass in motion. So momentum, we already heard about this, diba? Especially in sports. Sport announcers will always say, yung momentum nandun na sa kabilang team. Kapag yung team na yon ay ang dami nilang puntos na nagagawa and the opposing team is not able to stop them from making any points. So, kapag naman sinabi ay nawala yung momentum sa isang team, the opposite, diba? They are on the losing streak. Hindi makapasok yung bola. Halimbawa, ang basketball yung pinag-uusapan natin. So, let's see if the way we use it in real life or in sports is actually related to the physics definition of the word momentum. So, in physics, when we say momentum, mass in motion. Simple as that. Mass in motion. Diba lahat naman ng object may mass, diba? And then, if that object which has mass is moving, we say that that object has a momentum. Okay? So definitely, from this definition, we can say that momentum is nakadepende siya. It depends. That's the word. It depends on two variables, which are mass and the velocity of the object. So in equation form, momentum will look like this. Rho m times v. Rho. Okay, rho equals m times b. Yung m nga ay yung mass and v is the velocity. So, if titingnan natin yung magiging unit niya, di ba? Our metric unit for mass is kilogram and then for velocity is meter per second. You will get kilogram meter per second as the unit for rho or momentum. Makita din natin sa formula na to, no, na yung mass at saka yung velocity is directly proportional sa momentum. That means na kapag tumaas yung mass ng isang object, tapos tumaas yung velocity, mas bumilis siya, tataas din yun yung kanyang momentum, di ba? Yan ang ibig sabihin kapag sinabing directly proportional. Okay? I also want to say something about the quantity. Siya ay vector quantity, no? Momentum is a vector quantity. So remember, when you're describing momentum, you have to tell me about its direction and its magnitude, di ba? Pag bibigay na kayo ng final answer, for example, 45 kilogram meter per second to the west or right, going to the right or going to the left. Okay, ganoon po. So let's take a look. Let's put it in the context of this picture. So sa tingin niyo, alin dito yung yung sasakyan na may mas malaking momentum? So of course, yung army, siguro yung army truck, no? Definitely yung army truck yung may mas malaking momentum. Because it's heavier. And then dahil nasa incline sila, di ba? Gravity will pull it downwards. So it will have speed, di ba? Bibilis yung kanyang speed as it is going down the slope. So definitely, pag multiply mo pa yung dalawang yun, di ba? Yung mass saka yung velocity. The army truck will have the greater momentum. A reminder, di ba? Momentum equals mass equals velocity. Although all objects has mass, tulad ng mga books na to, if it is not moving, tulad nila, naka-stay at rest lang, di ba? Wala silang di ba? Momentum. Kasi multiplication yon. Mass, kung gaano man siya kabigat, di ba? equals velocity. If the velocity is 0, mass times 0, that will equal to 0, diba? Oh, this one has a momentum because the books are magically moving. Oh, some objects naman, 'di ba? Although they are very small, but if they are moving very very fast, they will still have large momentum, 'di ba? Like a bullet. It can pierce through human flesh, 'di ba? Even kill someone. Now imagine an atomic bomb, 'di ba? Drop from a high place, a high altitude. Tapos ang laki na niya, 'di ba? Ang laki ng mga bomb. O imagine the momentum na meron yung bomba na yan when it hit the ground. O halimbawa, in this caricature, halimbawa ikaw nagreklamo ka, grabe naman yung buhay ko, parang wala sa akin yung momentum at this moment. Pero nakasteady ka lang naman, di ba? Wala kang ginagawang velocity or change in position. So, zero ang momentum mo kapag ganon. So, maybe you should do something about it. Let's solve some sample problems. Okay, so we can try the equation rho equals mass times velocity. This is number 1, number 2, and number 3. So calculate the momentum of a 1,200 kilogram car with a velocity of 25 meter per second. Oh, simple substitution lang to, no? Nothing complicated. So 1,000 kilogram times 25 meter per second. Oh, yun lang po. You just get the product. So your answer will be 30,000 kilogram meter per second. So ganito po talaga kahaba yung unit ng momentum. Wala siyang, kumbaga, katulad ng Newton, di ba? Ang Newton ay kilogram meter per second squared. But when you combine them, may N or Newton na lang siya. In momentum, wala siyang ganun. So second one, you're given with kilogram. So definitely you're given with mass, and then you're given with kilogram meter per second. So that's momentum. Let's get the formula. So you're given with this, you're given with this. You're looking for velocity. What is the velocity of the vehicle? So we will divide, kasi dito yung velocity. We will divide it by mass, both of sides of the equation. So we can cancel, and then we are left with rho over M. So V equals, so what's rho? 7,800 kilogram meter per second, 1,200 kilogram. We cancel the kilograms. We are left with 6.5 meter per second. Okay? Okay, sige, very simple naman. The answer here will be 0.035 kilogram, or in grams, 35 grams. You can try that out if you have, or if you want to try the equation. See you on the next section.